Alright, so this is exponent rules with negatives. Alright, so if you look at this one right over here, you have a to the negative m, and it becomes this. And you have this one, it becomes this. Well, so I'll give you a little hint. We're trying to decide is why does that happen? And what I did is I drew a little division line. So you can see the division line here and division line here. And you may be thinking, oh, it flips. It's not that. It's not flipping. Alright, so what it is this. The little negative is causing this base and exponent to move across the division line. So that's what it does. It causes the base and exponent to move across the division line. Kind of like this. So here's how I look at it. If you have a to the negative m, and I'm going to put a border, that's our division line. You think of it like this is his body right here, his little legs, and he's got an arm coming up, and this is like his hand. Those are his fingers. There's his little head here. It's a little tiny head. So you have a to the m, and he's holding a little ticket, and what that ticket is something that allows him to fly across the border. So he has a ticket. He's going to fly across the border. And as he does, you take his ticket. So that's all it's doing. That little negative allows that base and exponent to move across a division line. So let's look at an example. We have negative 2, x to the negative 2, and y to the negative 4. Now that's not a negative exponent, it's just a negative number. So you can think of it like a little grumpy number. But these two have tickets. So the negative 2 must stay put. He cannot fly. Y to the negative 4, you take him across the division, and you take his ticket. And then x squared you bring down, and again, take his ticket. And there you go. That's the answer. No negatives, that's the key. It's kind of like you don't want to have an airplane ticket and never use it. So you're trying to get rid of all of them. Let's try another one. So over here, I like to circle everything with a negative exponent. That's how we started. Alright, and then anything without an exponent, without a negative exponent, you rewrite. And then now you can move it. So x is negative 5. We take that x to the 5 up, take his ticket. Take the y squared down, take his ticket. Take the y8 up, and take his ticket. And then now we can reduce. That 4 and 8 reduces to 1 and 2. The y squared and y8 reduces to y6. And that gives us an answer of x10, y6 over 2. And there it is. That's your answer. Let's try it again. Let's have you try these two. So hit pause and try them. And there are your answers. Check them over. Make sure they're correct. Let's try another one. Alright, so here's the next type of problem we have. If you notice, the exponent here is on the outside of a parenthesis. So whenever that happens, it causes everything on the inside to flip because we're giving a ticket to every single factor inside. So they all have tickets, they all travel. So why does the inside flip? They all get tickets. Alright, so if we have a negative on the outside, we flip the whole thing. Now I'm not going to simplify these, I'm just going to use the tickets. That's it. So on this one, we would flip everything, take his ticket. And then here, this is not a flip. So just this one has a ticket, so he moves up. So we get 4 times 4 squared. And since there's no more division, there's no reason to write it. Alright, this one has a ticket, and this one has a ticket, but there's no division line. So if there isn't one, you draw it. So 3 cubed will stay put. And the other two, the 3 squared and the 3, 4, will go to the bottom. But you must put a multiply because these are not variables, so we don't get to assume that there's a multiplication. Alright, if you have a plus in between them, you don't flip the whole thing. You treat pluses like commas, which means there's one problem here and one problem here. So that one will move down and make a fraction, plus, and then that one will move down and make a fraction. And then now we can use our addition of fractions, which means find a common denominator. But if you ever see a plus, you must separate it. And that's why I like thinking of it as a comma. It's this one and this one. All right, so that's all the different types we have. And again, they still need to be simplified, but we're going to move on. All right, so here's everything together. And the way I like to approach them, there's a lot of different ways. As long as you use exponent rules, these will work out. But I like to approach them with order of operations. So we do groupings first. So that's the first grouping. Okay, so we got our grouping. And remember, we're circling into with people with tickets. So 4, x, 5, and 8 stay put. That x5 goes up. That y squared goes down, and y8 goes up. So we moved y squared down, took his ticket. X5 up, took its ticket. Y8 up, took its ticket. Now we can simplify. So this would give us, we get a red, 1 and 2. That y squared will cancel that one and leave us with y6. So we're left with x10, y6 over 2. Okay, and then now we can move on to the second step of order operations, which is exponents. And since we have a negative on the outside, we must use our ticket, which allows everything to flip, to travel. We took the ticket. And then now we just square everything. And I like to rewrite them twice. That way I don't miss any factors. Okay, so that gives us 2 times 2, which is 4. x10, x10. It's x20. y6, y6. That's y12. And there's our answer. All right, try the next one. I've got it already started for you. So I drew some borders. All you have to do is kind of think about it. Hit pause, give it a shot. And there's the answer. So I paused it and showed you all the steps as I went. All right, thank you.